This lesson is titled The Power of Compounding. We'll learn to calculate simple interest, compound interest, and we'll understand the difference between APR and APY. A few definitions. So principal is the amount of money borrowed or invested or the amount of money on which interest is paid. Interest is the cost of borrowing. So if you take out a loan, there's usually an interest rate associated with that because you're borrowing money. If you are using a deposit account, like a savings account that accrues interest, that's how much you're making. Okay, so interest could be used depending on if you're lending or saving the account. APR stands for annual percentage rate, and it's interest for a year period. Simple interest is interest paid only on the original amount borrowed or deposited. So I say borrowed or deposited because if it's a loan, it's borrowed. Usually loans don't have simple interest, or a deposit account like a savings account. I stands for interest, P stands for principal, APR stands for annual percentage rate, and we work with this as a decimal when we're doing calculations, and T is the amount of time. Example 1. You invest $1,200 in an account that pays simple interest of 2% for 4 years. How much money will you have at the end of 4 years? So I'm going to do this problem two different ways. First way is more conceptual, where we'll talk about how much money is in the account after year 1, year 2, year 3, year 4. And then on the next slide, I'll go through the formula. Okay, so this 2% is our APR, and as a decimal, it's 0.02. 1,200 is our principal, the original amount that's invested. Okay, so at the end of year 1, this account is going to accrue 2% interest on that 1,200. So let's calculate what that interest would be, and it's going to accrue $24. So year 1, our amount in the account is 1,200. The interest is 24. So at the end, I'll have $1,224. Back to draw. In year 2 now, the amount in my account is the $1,224 because it's accrued interest. The interest for year 2 is still $24. Simple interest is the interest on the original amount borrowed. So this 24 for simple interest is not going to change. So we're still going to add $24. So at the end of year 2, we'll have $1,248. Year 3, I have $1,248. Again, $24, so $1,272. Okay, and then for year 4, I have $1,272 plus 24, which gives me $1,296. So at the end of 4 years, that is how much money I'll have in the account. Next, if we use the interest formula, this formula, notice I stands for interest, only gives us the amount of interest that'll accrue. Okay, so when we're plugging in our values, the principal is 1,200, our APR is 0.02, and our time is 4 years. In this case, you could plug this into your calculator to get 96. Now, is $96 the amount in the account? That just tells us how much interest there is. To get the amount in the account, add the principal plus the interest, and we get 1,296. Okay, so we get the same result either way. I just wanted to show you on the previous slide exactly how this is being calculated. Next, we'll talk about another type of interest, which is compound interest. Compound interest is paid on the original amount and on any interest that's accrued in the compounding periods. So the formula for this is A equals P times 1 plus APR divided by N, and then N times Y. Okay, so A is the amount, P is the principal, APR is the annual percentage rate, again as a decimal. N is the number of compounding periods per year, and for some reason Y didn't show up, it's the number of years total of the loan or the investment. Okay. So there are some key words when it comes to compound interest. Annually, compounding annually means it happens once per year, semi-annually is twice per year, quarterly is 4 times per year, monthly is 12 times per year, weekly is 52 times per year, and daily is 365 times per year. And I'll just add a little note, if we're talking about continuous compounding, there's a separate formula here. E is a button in your calculator. I don't think we do any of these problems, but I did want to bring up, like if it's compounding nonstop, 24/7. Okay. So example 1, use the compound interest formula to compute the balance in the following account after the stated period of time, assuming interest is compounded annually. Okay, so we're investing $7,000 at an APR of 0.9% for 18 years. So $7,000 is our principal. Our APR as a decimal is 0.009. It's compounded annually, so that means n is equal to 1. It's going to compound once during the year. And 18 years is our y value. So we plug this into the formula. And now I know I can simplify some of these, but we have P, 1 plus our APR divided by the number of compounding periods, times that number of compounding periods times the number of years. Okay, so before you put this in your calculator, you can simplify a little bit. Okay. And so I'm going to put this in exactly how it's written. 7,000 parentheses 1 plus, forgot a 0, 0.009 raised to the 18th power. So I would have $8,225.06. Okay, so what compounding interest does as opposed to simple interest, I should have left myself another slide, is after the first year, we're investing $7,000 and it's accruing 0.9% interest after the first year because it's compounded annually. So we'd have 7,000 times 0.099. It's going to add $63. So this is 7,063. Year 2 now, instead of using that 7,000, we have the amount 7,063. But instead of using $63 like we did with simple interest, we're going to count the interest on the new amount in the account. So 7,063 times 0.009 is 63.567. So a little bit of a better deal. So I just wanted to show that as the difference between simple interest and compound interest. Simple interest, you're using the same interest amount throughout because the interest is only calculated on the original balance, whereas compound interest takes the previous balance from the compounding period into account. Okay. Use the compound interest formula to compute the balance in the following account after the stated period of time. 17,000 invested for 4 years with an APR of 5% daily compounding. So 17,000 is our principal, 4 years is our time, our APR is 0.05, and daily compounding means 365 days. Okay, so we'll put this in the calculator, and I'll talk about how to put it into the 2 different calculators that are allowed for this class. So A is equal to 17,000 times 1 plus 0.05 over 365 raised to the 365 times 4. Okay, so this is the formula that we're going to use. If you're using the Casio, it's a little bit friendlier to put into the calculator. So I'm going to put it in and show you what it looks like so you can take a picture of it. So let me start. Okay, so with the Casio, because of the multi-line feature, this is the first part. I hope that's showing up. And let me scroll. When you do your exponent, you can just put in 365 times 4. Okay, and if you're ever having trouble with putting this in your calculator, you can reach out to me and I'd be happy to help you. Except on an exam, you have to know how to do it there. Okay, so this becomes 20,763.56. If you're using the Texas Instruments, I would simplify just a little bit before you put this in your calculator. I would do 17,000 times 1 plus 0.05 over, and I would multiply the exponent so that when you put it in, there's no confusion. Your calculator will follow order of operations. So if you're not careful, it'll do one exponent and then multiply the entire thing by 4. Okay, so this would be 1/4. So now this green is what I would put into the Texas Instruments. So 17,000 times, and when I put in the parentheses, make sure you put parentheses in, but it's parenthesis 1 plus 0.05, just the division, 365, and then use the caret, this guy here, to 1460. Okay, and we come out with the same amount. Okay, so as you're doing these problems, make sure you're understanding how to put them in your calculator. Example 3, how much should be deposited today into an account that compounds quarterly with an APR of 4.8% in order to have $50,000 in 5 years? So this problem is working a little bit different. If it's saying how much should be deposited, it's asking for the principal. Okay. Our APR is 0.048. This is the amount now because our goal is to get to 50,000. Y is 5, and then since it's compounding quarterly, N would be equal to 4. Okay, so in this case, our amount is 50,000. Principal times 1048 divided by N, and then N times 5. Okay, so notice here, oops, I forgot an equal sign. In order to solve for P, we're going to have to divide whatever this stuff becomes. Okay, so there's a couple of different ways, again, to do this in the calculator. If you're using the Casio, I'll show you what that looks like. Okay, so the Casio, since we're dividing, it allows us just to solve for P. And the reason I'm not putting it in my calculator first in dividing is because you'll introduce rounding errors. You have to keep the number the same until you round at the end. So for instance, if I were to put this, the 1 plus 0.48 divided by 4 raised to the 20th, I get a long decimal. I can't round it yet. I need to keep this number in the calculator. Okay, so if you're using the Casio, you can put it in your calculator just like what's written on the left-hand side. You would use the fraction button, okay, and then you would put 50,000 on top. And then in the bottom, make sure you keep parentheses where they are in the original problem. Okay, use the fraction bar again. Divided by 4. And then you would use your exponent raised to the 20th. Okay, so that is what goes in the calculator if you're using a Casio. You'll do essentially the same operation in the Texas Instruments, but you'll have to enter it a little differently. So we get 39,387.62. Typically, we'll round money to the nearest cent. So what this is saying is that we would have to invest $39,387.62 today for an account that compounds quarterly with an APR of 4.8% in order to save $50,000 in 5 years. If you're using the Texas Instruments, we still need to take 50,000 divided by that long decimal that I showed you. But what I would do first is I would put in the 1 plus 0.48 divided by 4 raised to the 20th. So get this in your calculator. And this is what the calculator is going to remember as answer. Okay, so we need to divide 50,000 by that long decimal without rounding it first. So what you would then do is type 50,000 in your calculator. 50,000 divided by, and then what I would use is there's an answer button here written in light blue. To get to it, you press second. So when I press second answer, it's going to remember that long decimal that was just in there right before the 50,000 and give me the same result that I got with the Casio. Okay, and again, if you're having trouble with the calculator or if you need any help with that, please let me know. We'll continue this lesson in the next session.